Hi everyone, welcome to the ICCII 1603 SP and 1612 Incremental Training. This is the timing analysis part 2. This is the agenda for timing analysis part 2. POCB enhancement from 1603 SP4. We have three enhancements for POCB. The first topic is flow variation. From 1603 SP4, POCB analysis calculation, the cell transition variation effect on delay variation. ICCII flow variation follows the prime time behavior. POCB flow variation can be used throughout the entire implementation flow, and it is also considered during optimization. POCB flow variation needs library-based POCB flow logic table in LVF for transition. Side file is not enough for POCB flow variation. Both POCB and flow variation must be enabled for POCB flow variation analysis. To enable POCB, time POCB enable analysis to true, the default is false, and to enable flow variation, time enable flow variation to true, also the default is false. Refer to OCVM-pi-POCVM will show the POCB flow variation data for a library timing R. To show detailed information on how flow variation affects the delay and the transition of the cell, you can use the report delay calculation command. In this slide, you can see POCVM delay sigma induced by input strength variation, POCVM combined delay sigma, POCVM output strength sigma induced by input strength variation, and POCVM combined output strength sigma. The second POCB topic is corner specific sigma. From 1603 SP4, the sigma value for POCB analysis can be specified on a corner instead of being applied to the entire block. This allows for more conservative or relaxed POCB analysis at the specific corner. This functionality applies to delay, constraint, and transition variation if they are all enabled. You can use set POCVM corner sigma dash corners for this feature. Without the corner option, set POCVM corner sigma will set the value in current corner. Without this command, time POCVM corner sigma option value will be used. If time POCVM corner sigma application option is set again later in the session, the corner specific value is overwritten, and last sigma setting applied is used. In the following example, the FF corner has a sigma value of 3.1. Because it applies the set option, time POCVM corner sigma dash value 3.1 at the last. Refer to OCVM dash corner sigma option will show the sigma value. In this example, POCB corner sigma is 4. Also, default timing header format is also changed for POCD analysis. Default timing header will display PO sigma value. The third POCD enhancement is LVF and coefficient pressure. Previously, file-based POCD coefficients took precedence over library-based POCD data, regardless of whether the coefficient was specified at the library level or at the design level. From 1603 FP4, the precedence of the data can be modified with an add option. This is consistent with prime time 1606. The precedence of every data and coefficient inside file is controlled by the time POCD precedence add option, which can have one of three values. The default is 5, which preserves the earliest behavior of a coefficient file overriding LVF data. With the library setting, POCD LVF data in the library override coefficient inside file. With the library cell in file setting, ICCII used the following priority in decreasing order of precedence to determine the POCD data that is used. Library cell table in coefficient file, LVF data. Hierarchical cell table in coefficient file. Design table in coefficient file. This feature only applies to delay variation data, since slew variation and constraint variations are only supported in LVF. Ungrouped cell enhancement from 1603 FP4. Previously, if there were timing constraints defined on a hierarchical cell or its pins, ungrouped cells does not work with error messages. From 1603 FP4, ICCII copies the constraints from the hierarchical cell or its pins to an appropriate leaf cell or leaf cell pins and ungroups the hierarchical cell. The selected leaf cell can have a use size only or don't touch attribute setting. Therefore, the tool selects the leaf cell that has the minimal effect in the design. From 1603 FP5, if the tool is unable to find an appropriate leaf cell to apply the constraint from the hierarchical cell or its pins, it can add a new buffer. 1603 FP4, if the tool is unable to find an appropriate leaf cell to apply the constraint, it did not ungroup the hierarchical cell. From 1603 FP4, to prevent the ungroup cell command from ungrouping a hierarchical cell with constraints, you need to set time ungroup enable inherit constraints to false. The default is true. From 1603 FP5, to allow ungroup cell command having new buffers, when it cannot find appropriate leaf cells to move the constraints, you need to set the time ungroup allow new buffer application option to true. The default is false. The constraints set by the following commands are supported by the ungroup cells command. Create clock, create generate clock, clock latency, propagate clock, clock uncertainty, input delay, output delay, false path, max delay, mean delay, multi-cycle path, test margin, group path, case analysis, disable timing, ideal network. The clock gating check, disable clock gating check, max time borrow, clock balance point, create clock queue group, timing rate, and set operating conditions. The ungroup cell command does not ungroup a cell if the don't touch attribute setting is applied on the hierarchical cell, or OCVM related timing constraints are specified on the hierarchical cell or its pin. A constraint is applied on an in-out pin of the hierarchical cell. Moving constraint to a leaf cell calls a coupler. For some delay-related commands, such as input delay, output delay, clock latency, clock uncertainty, clock period clock, generate clock, then mean delay, set ideal network, the tool does not adjust the delay when moving constraints to a replacement pin. These are new warning and error messages for ungrouped cell enhancement. This slide shows 8 new messages from TIM 305.1 and T358. I will skip reading all these messages. Net and wire capacitance attributes from 1603SP5. From 1603SP5, the following net and wire capacitance attributes are supported. Wire capacitance min and max. These attributes represent the wire capacitance of the net for minimum and the maximum conditions. Total capacitance min and max. When CCS ratio model is not enabled, this attribute represents the sum of all load pin capacitance and wire capacitance of the net for minimum and the maximum conditions. If the capacitance is displayed in the timing report for rise and fall are different for the same net, the total capacitance min and max attributes are the worst of rise and fall values. If a net is in both the clock and the data path, the total capacitance min and the max attributes are the same for clock and data path. Total CCS capacitance min rise fall, total CCS capacitance max rise and fall. When CCS ratio model is enabled, these attributes represent the sum of wire capacitance and the CCS receiver capacitance for minimum and maximum rise and fall conditions. If a net is in both clock and data path, each attribute is the worst of the two values of the clock and data path. This is the example with the CCS receiver model is not enabled. Total capacitance max is 0.01346, which is consistent with the timing report with the rising edge here. However, timing report with falling edge shows smaller values than 0.01346. With this example, capacitance are different between rising and falling edge, and worst value are shown with the capacitance attribute. This slide shows wire capacitance min and max values, which are consistent with the report related calculation values. Ignoring register-to-register passes within subblock from 1503SP5. During time-level optimization for hierarchical design, you might want the tool focus on the top and boundary logic and ignore any register-to-register critical passes within the subblock. From 1503SP5, you can disable register-to-register passes within some of all subblocks by using the set time path disable block command. Then, time-level optimization ignores the register-to-register path in the specified subblock. Two new commands are added. Set time path disable block will ignore the internal register-to-register time path within subblock. remove time pass disabled block will restore the register to register time passes within some block previously ignored by the set time pass disabled block command. Here are examples. Set time pass disabled block is block 1, block 2. Then all time pass within block 1 and block 2 will be ignored. Time pass across block 1 and block 2 are still valid. Set time pass disabled block is all subblock. All time pass within subblock will be ignored. Again, time pass across any block are still valid. Remove time pass disabled block. All time pass within subblock are valid again. Default timing dash start and tail command from 1603 SP5. From 1603 SP5, start and tail option is added to default timing and get time pass command. Default timing dash start and tail command reports passes for each start point and end point pair based on connectivity. By default, this option searches only for the passes that are violating. This default can be changed by using select less than option. If the design has multiple scenarios and pass groups, the tool merges all the scenarios and groups all the time pass together and reports only one path to the same start point and end point that has the worst flag. Start and tail option does not work with the n-worst, next path, and report by option. Using prime time delay calculation in timing analysis and optimization from 1612. From 1612, you can use the integrated prime time delay calculator in ICCII when doing post-route timing analysis and optimization using the route of command. It will improve accuracy and correlation with the prime timing tool. With this capability, the tool uses the .d files of the reference library in addition to MDM library. The .d files of the MDM reference library must be accessible by ICCII. If the original .db location is changed, then use searchback variable to include the new location of the .d files of the reference library. Enable this feature by setting the time use PT delay app option to true. The tool does not use prime time delay calculation mode for the first route of command you run. If it identifies it is the first route of command you are running on the block, the tool automatically uses the native IC compiler to timer. Prime time delay calculation mode does not support CCD optimization and CTO during the route of command. This is the flow overview. After finishing route of the RM flow, PT delay calculation is enabled here. This is the recommended post-route optimization flow usage. Complete route of the RM flow with the ICCII native timer, because the prime time delay calculation based on route of command does not support CCD and CTO if they are required. Perform them during this step. Enable PT delay calculation and then run route of command without CCD or CTO. So set option name time use PT delay value true and then run route off. These are PT delay calculation related messages. You can check TIM 200 and 201 for update timing log file. So here is the example. Information. Update timing is using prime time delay calculation. Or warning. Update timing will revert to use native delay calculator. You can also check route of log file when whether PT delay mode is enabled or not. This is the end of ICCII 1603-SP and 1612 Incremental Training Part 2. Thank you for your attendance.